Hi guys, hi everyone. My name is Maciej Zasada. I'm a tech lead at Unit 9. Also at the same time, I'm the founder of Le Polish Bureau, which is basically a Unit 9 technical department in Poland. I'm also an FWA judge. Not sure if you're familiar with this contest and kind of award competition. You also have my contact details. I'm going to repeat them at the end of the presentation, so don't worry. Before we dive too deep into the actual topic, I would like to give you some context for how you should approach this presentation, what to pay attention to. So first of all, the aim of the presentation is to inspire you with Polymer, with what it can do, so basically to show you the possibilities. It's also to show you use cases from a pretty big, and I would say, at least compared to other applications we were talking about today, quite an unconventional project. But it's not to teach you Polymer from the basics to the very end. So if at any point during the presentation you find yourself wondering how exactly does it work, what's this thing, just try to kind of focus on the top level idea and on the use case, on the use context. And you can also just go back home and read something on the internet and get a bit more information about this. In terms of where I'm coming from, what is Unit 9? Unit 9 is a digital production company, but we also focus on innovation. There's a couple departments. Overall, we do cool stuff for marketing purposes. Unit 9 is currently the most awarded digital production company in the world. Myself, I've been involved in multiple projects at Unit 9. Just to name a few: Find Your Way to Oz, which we did for Disney and Google. Kingsman, the Secret Service, which was done for 20th Century Fox, or Just a Reflector, which was a second screen experience that we did for Arcade Fire with Google. And in this experience, you could basically use your phone as a controller in a way, but also from a conceptual point of view as a digital projector, reflector, which was casting kind of digital effects on top of a music video. And actually, this project is quite important in the history of Star Wars, the Lightsaber Escape, because when 72 and Sunny, they are basically a marketing agency, when they came to Unit 9 asking, can you please help us determine the extent of motion sensitivity and also graphics performance when it comes to a lightsaber training second screen experience. I was basically given the task as a tech lead to basically prove that it can be done and also how we can do it. And that was kind of because of the experience I had from Just a Reflector. So we approached this, said, hey, we can do the full project, but let's start with a prototype. That's going to be probably the wisest solution. So this is what we did. We spent a couple weeks, wrote everything completely from scratch, having in mind that Google is one of the clients. You don't want to use engines like Unity. You just want to do things in kind of JavaScript. So we didn't use any game or physics engine, just FreeJS, CoffeeScript, WebSockets. And we did something which was definitely rough on the edges, but I think it was already proving that the result can be achieved. So let's have a super quick look at what we did at that given time. So that's the prototype. Definitely, as I mentioned, rough around the edges, but you could already use your mobile phone to control the lightsaber. It had not a lot of latency, and also the visual quality was pretty good at that time. So this is how we started. We've sent this back to 72 and Sunny and awaited the verdict, and yes, it was a win. So we did it, we made the prototype, and basically were given the full project to be made. So we partnered with Google, Disney, ILM. It was quite a big one because it was basically the main digital piece for the upcoming film, Star Wars The Force Awakens. So We had lots of brainstorming with these guys. We went to Los Angeles to also work with them directly. But during one of those meetings, we realized that basically according to Google, we have to use Polymer to build this project. And at this point, we have to be honest. We knew about Polymer, but we haven't used it before. So same as I'm going to do it with you now, we went through what is Polymer in general. So, well, Polymer is a web components library, and that's what you can find on the website. Let's see what web components are. So the definition says that the web components is actually a set of standards currently being produced by Google engineers as W3C specification that allows for the creation of reusable widgets and components in web documents and web applications. Okay, that already gives us some insight, but how does it actually work? So this is a sample code of a very simple, almost not doing anything, Polymer element. So you start with element definition, and then everything is encapsulated. It's basically an HTML file, so you save it as an HTML file in the end. And you begin with the element definition, then you put some styles in, then some template, which is basically the HTML code that goes into the element when you use it in your application, and then you give it some logic. Okay, so if we have those three components, it means we can do pretty much anything we want. And this is how you use the element. It's once it's written, you start by importing some polyfills. That's just in case your browser doesn't natively support web components. Then you import the actual element. So that's the file you wrote in the previous step. You just use import. And then you can already use it. So using the custom tag that you defined as the kind of element name. You can pass it some parameters, and the result is, as you can see here, for example, a map, which is fully interactive. So basically a full kind of working component. But what can you actually use it for? So kind of going back to the definition, not sure if you realize this, but basically the only thing it states is that you can use it for reusable widgets or components. But can we actually build a full application using Polymer? And that's the question we asked ourselves when we got to know that we have to use Polymer in this project. We did lots of investigation. We've read pretty much all the documentation, and we concluded that yes, we can actually build a whole application using Polymer. So let's just go and do it. But before we see how we did it, let's see what we actually did. So it's going to be easier to talk about it later.
It's never been made possible until now. We partnered with Star Wars.
We've got some sound issues. I'm not sure if there's anyone who knows what's going on, but part of it is not heard. Okay, let me turn off the mic, and let's see if it helps.
It's never been made possible until now. We partnered with Star Wars. Basically, we turned your phone into a lightsaber, which you could then use to battle stormtroopers on a second screen and escape the First Order. Every move, every push, every tilt, swipe, or jab was matched in real time across the web, all in hopes of escaping faster than any of your friends.
I see I have to do dubbing.
They reviewed it, recorded it, played it together, and then took it to the next level.
And you didn't get the joke in the end. Yeah, we'll check the sound issues at the end. Cool, but you can still play it. Sorry for the sound issues, it was super weird. Part of it was on, part of it was not. But this should give you quite an idea of what we actually did. So that was a 3D game. It was controlled from a mobile phone. You would use it as a lightsaber, just to, like, kind of bring up the design. This is how the landing page looked, and kind of the UI you would get on the mobile phone. So how do you use Polymer as the underlying framework for pretty much everything that you see in this video? So first of all, if you approach a bigger application, you have to make sure the code is maintainable. And if you recall the example I gave you in the beginning, where you had this kind of, a bit lengthy HTML file which had CSS in it, HTML in it, JavaScript in it, it's not really a way that's going to be maintainable. So the first thing we did on this project was to come up with a file structure which is going to be reasonable. So first of all, we've split all the Polymer elements into individual folders. And inside of those folders, we had separate files for logic, for the visuals, so basically styles. Before I get too deep into it, so you can already see we used CoffeeScript and Sass, and we also used Jade instead of raw HTML. Some of the snippets will be in those languages. If you have any issues with this, just try to ask questions, or hopefully it becomes clear anyway. And so the interesting thing is that besides splitting the code into files, what we also did was we placed Bower JSON files in each of those elements. So basically each element could define its own dependencies and its own libraries it would use. And why did we do it? So first of all, you can think about a situation when there's a library which is required for by only one element. So if you delete this element later, you no longer need it, you would have to remember to go back to the global Bower JSON file and remove this library as well. So in this case, if you just remove the folder with the element, the Bower JSON gets removed as well, and the dependencies are lost as well. So that's pretty cool. But you may ask a question like, what happens if you have multiple elements that actually require the same library? So that's going to be tricky, because then every time, the library will have to be downloaded and kind of placed in Bower components folder multiple times, once for each element that requires it. So we found a pretty cool solution for this. We used the Bower RC file, which is basically just a pointer to the folder where Bower components should be stored. So this file, in all the elements we had, was pointing to the very same folder. So the result was that when the first file, which was requiring a certain library, would download it, the library would be placed in the same Bower components folder as for all the other elements, and then when they try to download it, they would find it already existing in the folder. So there would be no need to download it again. So it was very fast. And then we had the Jade file, which was pretty much just merging everything together. And we can have a look at an example. So this is the Jade file, which basically at the top it was importing some libraries. Then it was importing also CSS from a separate file. Then it was pretty much just focusing on the actual HTML code. In this case, it's Jade, but it just compiles to HTML. And it was importing the scripts from a separate file as well. So this way, we had a modular file structure. But you can also ask a question, okay, so this file structure is quite complex. So now we have maintainable code, but we have a very difficult structure to maintain, and it's quite mundane to keep creating those folders in this certain manner. So what we did is we created a / generator, which was it was a simple command line execution. You give it the name of the element, and it was creating the correct folder structure. It was instantiating and initializing the respective files, and it was also pre-populating the Jade file with correct paths to be included and imported. So then when you wanted to create a new element, you already had the basic structure done by just a single command. / by the way, is an alternative to Yeoman, and it reuses gulp. So if you already have gulp in your project, it becomes very easy to integrate it without any other dependencies. But okay, so we've got the project structure, but how can we actually, the file structure, but how can we actually structurize the project itself? So Polymer and web components is pretty much just document object model, so you can use nesting. Here you have an example of the actual debug panel we had in the development version of Star Wars. So it was showing things like version information, performance stats, some WebGL insight. So the easy way to do it in Polymer is simply import all those free files in your debug component, and then simply place the tags within your HTML code. Simple as that. You can kind of encapsulate other elements into one element and create this kind of components. So if we can do it, if we can put other elements within other elements basically, this means we can pretty much just create the whole application element in Polymer as well. So this is don't worry about the code, it's just to show you the whole application, the whole front-end part, the desktop application that you saw, that was the topmost element. And even if you think about pretty much any application, just saying the words really quick, what does an application consist of? Okay, so it's got some services, it's got some, more services, it's got some pages, maybe some kind of persistent and global overlays, and everything else can be just nested within those components. So this is what we did. We created the basic app element. We've put some services, pages, as I mentioned, and overlays. And the other cool thing about Polymer is that when you want to prototype something quick and just create the results in a few minutes, you don't have to worry, you don't have to know the framework super well and worry, okay, so is my routing component, is it going to be a service? Is it going to be a controller? Well, it's certainly not a view, but what about pages? Where do they fall into? What about overlays? Polymer is super simple for this reason. The only thing you have in Polymer is elements. So you have an application which has services, pages, and overlays. You just create multiple elements the same way. You've got services, pages, and overlays. You can already put the structure in place, and you can just start writing code afterwards. So it's very quick to get things running. The next thing about Polymer is properties. So let's focus on the renderer. This is the example I'll be using throughout the rest of the presentation as well. So just to give a bit of context for those of you who haven't worked with 3D applications or games, a renderer is basically something which gets information about the 3D environment, the models you use, the geometry, and about the camera, for example, and then it just renders it out to a flat image which is displayed on the screen. So let's say we've got this renderer used in our HTML code, and we want a quick way to enable or disable anti-aliasing, but not for the user. We don't want the user to be able to switch it off, just us developers programmatically. So in Polymer, you can define properties. You can give them. So this is the right-hand side. You define. You can assign types to those properties. So we have anti-alias and auto-resolution property here in the renderer. And you can then read the values, Boolean values in code, the way you have it here at the bottom. So the @ sign in CoffeeScript is just a reference to this. So it's like if this anti-alias, then this setup anti-aliasing. And you can trigger those properties on and off by simply adding attributes to the element. So if the attribute is if it exists, then the value is true. If it doesn't, the value is false. Super simple, super easy, and you as a developer can kind of configure elements in a very quick way. Some of you may have already noticed that in the previous examples, we've had this ready function. So Polymer also has callbacks, lifecycle callbacks. So if you define a function in your element, which is named either ready, created, attached, or detached, then this is the callback function, and it's basically triggered upon one of those like key events of your element. So ready is when the template has gotten computed. You can use the HTML which is inside. Attached is when it gets added to DOM. Detached is when it gets removed from DOM. So it also makes maintaining kind of the life cycle of the application very easy. Okay, so we've got multiple elements. We know how to define properties. How about communicating between those elements? So in Polymer, the native way of doing this is data binding. So let's kind of broaden the context of the renderer used in our application a bit more. So what I told you is that it needs to know about the camera and the geometry. Like if you want to talk about the geometry, you can pretty much just simplify this by saying the scene. So the scene is like in any 3D software the content of your 3D application. So how did we do it? First of all, we had a Polymer element which was called the model. So the model was just like a JSON configuration. You can imagine like exporting your 3D scene from a 3D software. So you have positions for objects, you have what type of enemy it is, how difficult it should be, what's the shooting accuracy, for example. And this element then, the model, was, let's say, data producer. So if you want to produce and expose data in Polymer, you use curly braces. So here we expose the model variable in this given context. Then we had the engine. So that was another Polymer element. The engine was basically instantiating all the geometry. It was using Three.js to create the 3D scene based on the configuration data that it was passed. So it was consuming the model that was produced by the other element. So once we have the scene created and the camera set up based on the model, we can also expose it. So the engine was exposing the scene and the camera, and the renderer was basically binding to the same values, to the same properties, and it had access to the camera and scene to be rendered. So this should give you an idea of how data binding works in Polymer. But like data binding is something you know from AngularJS, from other kind of methodologies. But Polymer is just a document object model extension. So let's see how it actually works. What if we just use the console and use document query selector and type the name of the tag? So the name of the tag was SW experience renderer. Well, it just returns the element. It's a normal DOM element, so that's pretty cool. But, well, hey, we also defined properties. We also defined some logic. So what if we try to access the anti-alias property? It's true, because if you notice, you had this anti-alias argument set. So Polymer parses it and sets the variable, the property, to true. The same way you can access functions. So basically, you can access any element from anywhere in code using simply document query selector, and you can access directly its properties, its functions. So communication between elements also becomes very easy. You don't have to worry too much about this. But of course, there's considerations about how kind of safe it is, how good a practice it is. So you can also just force yourself to limit this to adding event listeners and firing events the way you do on any other DOM element. Another thing is parent-child relationship. So how can we utilize this in a bigger application? And this is actually a very cool thing. I was like quite happy with the pattern we achieved here, although it's very, very simple if you look at it now. So we have a post-processor. Post-processor is basically a part of the renderer which applies visual effects on top of the already rendered image. So it can be things like bloom or vignette or blur. So what we did is we created the post-processor Polymer element, and we put the actual effects post processes to be rendered as its children. We gave all of them the same CSS class. That's basically just a Jade way of adding a class to an element. So both of them had the effect class. And what can you do with it then? In the post processor's code, you can use just the regular query selector to get an array of all children which have the same class. And then you can iterate over all of them and, for example, add them to the composer. So if you want to add more passes, more effects, sure, just put one more line of code in the template, and that's going to be done. If you want to remove one, just comment out this line, and the rest of the code is not going to break. So that's something I really love about Polymer. And people have taken it to quite an extent, and I'm not going to explain this example, but that's pretty much just 3JS as the whole 3D engine, which was rewritten in Polymer, so you can create the full 3D scene, all models, all geometry, materials, textures, with just document object model, with just HTML, not writing any single line of JavaScript code. So now when we have the application built, we can try to optimize it. So you have multiple elements. This leads to numerous imports, and this results in multiple HTTP requests. So that's not good. With JavaScript, you do minification. With Polymer, you do vulcanization. That's, basically the same concept. Polymer has the vulcanize, kind of plugin utility. So it traverses the whole tree of your elements, and it outputs just a single HTML file. So the cool thing about this is that because it pretty much just outputted our whole application as one HTML file, it means you can now give it to someone and say, hey, actually, you know what, put the Star Wars application as a module on your website. So what the person has to do, just import the Polymer library, import this one HTML file, and add the application tag to HTML. 3 lines of code, whole application is included, no dependencies, no kind of conflicts. Super, super cool thing about Polymer. Couple things about performance. So we actually had a Google performance review. So, we had a Google performance review. So there was a person from Google, from the Chrome team, who analyzed this application and found out a very strange thing, that we've got one block of code which is sometimes executed multiple times, and this execution is taking much more than a single animation frame, which was actually doing all the rendering, all the kind of physics logic, and so on and so on. So what is this? And it appeared that when the mobile phone was sending data to the front end, if it sent more data than we were able to receive during one animation frame, during the next animation frame, it would then try to call kind of the data binding mechanism and also kind of the triggers for data change multiple times. So this resulted to big performance impact, and we had to remove the Polymer dependency in this area of code in the end. Or you could also try to optimize it with Polymer as well, but that was one of the problems. Another thing here, very similar, is that another portion of our code was taking quite long to execute compared to the animation frame. And we were actually very sad about this, because what this piece of code was doing is we thought, okay, so when you have a game, when you have something which is getting rendered, it heavily relies on the request animation frame. So we thought, okay, let's do it the proper kind of Polymer way. When we wrote this, we thought this way. So let's create a timer element, which is going to expose t and dt variables properties, so basically time and delta time, and it would change those values with, it would only use the request animation frame, but all the other elements that need request animation frame which basically just bind to this element via properties. And we thought, okay, that's going to be cool, because if we pause the timer, everything else is going to pause, and that gives us the control. So we did it this way, but apparently, if you consider a single animation frame, the amount of time data binding was taking compared to the rest of the logic was too long for us. So when you fight about every single frame, if you count frame rate per second, then this was too much. So this brings us to conclusions. First of all, Polymer is great for modularity. It really, lets you separate the code, logic, style, everything has got its own place. It's also the native HTML approach. So you use document object model, and you don't use kind of, overly complicated frameworks. It also abstracts concepts with DOM. So you can see, for example, the render, how we did it, how we made the post processor utilize multiple passes with document object model. It really changes the way you think about code. You can basically just do it with HTML in terms of the structure, in terms of the core concept. And it's still a modern architecture because you've got data binding, you've got events, you've got properties, you've got lifecycle callbacks. You can restrict the type of your properties. So that's pretty cool. And it's very quick for coding. Whenever we do a prototype now, we use Polymer. It's very quick. And it's also lightweight. So a good kind of opposition to Angular. And it's highly isolated. So as I mentioned, you can export the whole application in a single element, and it's compatible with other frameworks. The two disadvantages from our experience when working on Star Wars Lightsaber Escape, it's got this performance overhead. I think for most applications, it's not a problem. It's really like, this time setter was taking 1.6 milliseconds from what I remember. But still, if you do it every single frame, it's not the best thing. So for games, for things like this, maybe not really the best framework to be used. And maybe this is over-exaggerated, but I wrote it myself. Like, it provokes spaghetti code. It doesn't really provoke it, but it lets you do it. So if you don't pay attention, you will be able to do spaghetti code because you can access any element from anywhere in your application. So it's pretty much the same thing as having globals. But if you pay attention to this, if you put a good structure yourself, you can make it. And if you want to make a mess with Angular, you can do it as well. So I still encourage you to use it. Let me know if you have any questions.
Hi, thanks for the presentation. It's cool to see the web components evolving. You said that if you vulcanize your app, you're not going to get conflicts. But as far as I know, if you vulcanize a library and then you import it with another import, you will get a conflict, right?
Yeah, so when you import libraries, it probably might lead to some conflicts. It's still, the library itself can export some, for example, global properties. I think it might happen, but in terms of like the internal application code that you're writing, it's quite encapsulated. So at least, in case we were actually asked to embed this application as part of another website, I think I would be quite safe with Polymer compared to other frameworks. But we haven't actually tested. No one hopefully asked us to put the Lightsaber Escape as a module on another website. So I can't guarantee this, but it's definitely created with this kind of concept in mind.
Okay, thanks. If I could, I have another question about the project structure in the Bower JSON file. Do you keep all your individual elements as in separate repos or in a single repo? And if you kept them in a single repo, how do you handle Bower updates that will override your other elements?
Yeah, good question. So the way that, for example, Polymer itself encourages to structure projects is to use separate repositories for all elements. We haven't done it. I think it would be just taking a bit too much time for us. It was just much quicker to write it this way. However, again, we kept the modularity in mind, and for this reason also we introduced separate Bower JSON files per every single element. So we had this in mind that at some point, if we have to, we can reuse them and put them on separate repositories, but we haven't actually had to use it on this project. In terms of the second question, how we managed Bower updates, the thing we did is we wrote quite a simple script, which was basically finding all Bower JSON files within the file tree and was executing Bower update on them. So if you wanted to just trigger Bower update for all the components, all the elements, it would just traverse the file tree and execute separate comments. This is I can agree that's probably a drawback, but how often in a project which you develop for 3 months, how often do you update Bower components? Like probably 3-4 times, but not too often. So that's how we did it.
Sorry, but I mentioned the Bower dependencies in between your elements, or you're not adding them to the Bower JSON then? Because if your individual elements written by you are the Bower packages, then you may include them in Bower JSON as well. And then your elements will be overwritten by the one from the repo.
Yeah, so in terms of the dependencies between the elements, we used a very simple approach at that time. Like that was our first project with Polymer. We didn't really define those dependencies. The way we did it is we just had one elements JSON file, elements HTML file, or Jade in our case, which was one huge import. So it was importing all our elements that we had in the application. So we didn't explicitly define the dependencies between those elements, even though that's probably a good thing to do. In another project we did in Polymer after this one, what we did is we at least had imports to those elements individually within every single element. It's if for example, the renderer was requiring the post-processor, it would import the post-processor HTML file within the renderer HTML file. So then, ultimately, if we delete renderer, we don't have any import to the post-processor as well. So that was helping. But yeah, that's still kind of, the area of exploration for us as well. But yeah, it gives you a couple options to do it.
Maybe one last short question? Short.
Okay, you used Polymer 1.0, not 1.2 or whatever, right? Because you used imports in styles. That's probably, yeah?
Yes, that's correct. Yeah. And I'll be still here after the presentation for a moment, so if you have any more questions, feel free to ask.